folks. Hang on. I'm gonna sit myself down here. This morning we're gonna talk about, it's a topic, Noel from garden tractors and firewood there. He got me on a topic of, he was doing a house for a guy. He was an electrical engineer, and he had the outlets in the house were all 220, 240, and he had transformers down to 120 volts, and he was wondering why, or maybe he knows, but then he just brought that to mind, eh? Well, when we start off, this is going to be a bit of a travel through time, if you want. We have to start right back to the supposedly inventors. Well, we know they are here in America, but in Europe, I'm not sure. Surely there's some people, maybe Marconi or some other people have claims to fame in electrical, and they had their own systems. But here in America, there was Thomas Edison, which is, he's known to be one of the initiators, and who is given most credit for, but there's another guy, and most know him a lot because they have a car named after his name. His name is Tesla, Nicola Tesla. He was just a touch on what they were all about in those days. Is Thomas Edison was pushing DC, direct current, and Nicola Tesla was pushing alternating current, and one was showing that his system was better than the other. What I know now that we're all the way through this is that DC, you can power things up with DC, but DC, to carry it for distances, you need a lot bigger wire. If you're going to put with the same load, let's say, if you got just to talk, let's say you had a bunch of lights on AC and you had them on DC, well, to give you the same amount, the intensity, you'd be pressed for putting bigger wire to carry the same amount of umping power. Okay, that's just to put them in a layman's terms. So, and something not to forget, and see, I worked in a mill. You wouldn't have believed all the differences. There was AC, and in the day that I worked in those paper mills and sawmills, there was AC, there was, DC, there was the DC 440 volts, DC 600 volts, and then there was AC 440 and 600, 560 to 600. And this was all within the same mills, eh? Initially, a long time ago, I'm talking in 1800s, if you had a motor and you wanted to control the speed, it was a DC motor that you would put. There was no such thing as controlling the speed. You had AC motors, they were three-phased. In the three-phase, they were either 440 or 600 volt. And, well, there was higher voltages than that. Well, we won't get into that here. But, okay, so if you wanted to, with step controllers, with resistances, you'd be able to control the speed on a DC motor. But when I started in the trade, these were just maybe 10 years in the trade. I got to see, and I worked on the first systems that came in, and they were made, I don't know who come out with that, companies. But the first systems where they would control AC motor, control the speed, and the way they control the speed is by varying the cycles, right? And they vary the waveform, and that would change the speed of the motor. And they can give the motor, the AC motor, different characteristics. And eventually, at the latter part of my trade years, they had they call those soft starts, and I could take courses into how to program. They were programmable controllers, eh? And this, you couldn't imagine what you could do with an AC motor, but initially, like in the well, not that long ago, like in the 50s, if you had an AC motor, you were stuck with the speed that motor was going to run at, and like strides and bounds into. But anyways, just we're talking about this. I was just to show that there was just different parts of the countries had different companies, and the here in Canada, okay, just one instance of different trains of thought. If you go up northern Quebec, there's a lot of little private companies that used to supply power to little towns, and they were all fed with 50 cycle, and so because of this, you could see the lights flickering all the time, eh? But hey, whatever. You see, depending on the generators and the systems they had to control the power and the availability and the voltage they were operating on, and everybody had their little thing, eh? And it all depended on what equipment you had. And excuse me, I think I'm talking a little bit too loud here. Yeah, so it's but what I wanted to say, okay, I should make notes, when I get into these topics, but I start gibbering and jabbering, and I forget all about what I said. The whole thing is, Thomas, what I wanted to say was Thomas Edison was credited for all the development in electricity, but really this guy, Nicola Tesla, is really the guy that pushed, and he got, there's no polite way of saying this, but I'm not going to say the word, but the guy that owned Westinghouse, I forget his name now, he's a financier. He took away all the money. See, he had signed some contracts with Nicola Tesla, and all that Nicola got. He died, that guy. He was as poor as... you know, it's terrible when you think about a guy that had so much intellect and well, he worked for Thomas Edison, and they were in a squabble all the way through to the end till he severed his relationship with him. And even Thomas Edison gave him grief, eh? Well, I won't go into, supposedly he electrocuted some elephants with alternating current just to show how dangerous that was. But anyways, that's maybe just stories, eh? Well, I wouldn't be caught repeating these stories, eh? Anyway, so our venture, okay, we as electricians, I was working at paper mill, okay, and this paper mill had DC control, okay, AC motors, they had 440 and had 600 volt, all in the same, well, different buildings, eh? But like we know when we went to the Ottawa mill or we went to Hull mill, well, the Hull mill was working with a certain voltage, and I think, I don't want to say, it's one or the other, okay? J.R. Booth or Eddie's, one of the two, I forget now. I'm not as young as I used to be. But one of them came from Britain, and they were 440, okay? J.R. Booth come from Eastern United States and Canada, so he was 600 volt. Okay, well, just one. See, even within the United States of America, there was, if you went from mid-state to the west, that was 440 volts AC. If you went east, it was 600 volt. And I remember working at a sawmill up the valley. I talked about that sawmill a little bit before. They bought a 24-inch two-face, 24-inch two-face upper and lower planer. Hey, the board goes through, and it's planing both sides. Okay, at the same time, it comes out, and it's coming out. They had so the boards wouldn't go through the wall. They had a slow down. It's a grippy type of belt. It would slow the piece down, and then the chain conveyor would pick it up going the other way. Anyways, okay, these planers had a 440 volt three-phase motors, two, one on each planing shaft, and we hooked them up, and I seen the nameplates on the motor when we hooked them up, and I talked to the engineer. The J. Boyle was the name of the outfit. I asked him, I said, hey, you're not changing the motors on those? Oh, he said, no. He says, we're going to run them, and when they burn out, we'll change them. Well, I seen that same engineer, because they were a division of the company we were doing work for, and I seen him at the mill, at the paper mill, and I asked him, I just went to see him, and I asked him, I said, so, I says, I'm curious how those, he says, one motor burnt about 4 or 5 years after the initial installation. One of the motors burnt, but he says the other one's still going. Well, that planer probably is somewhere else now, because that's closed down altogether, that place. But that used to, like, output was incredible. The amount of wood that planer would go through in a day. But anyways, it's just to say, like, it has to do, okay, the different voltage. Like, if you have a 440 volts where your insulation on the wire is not as good, okay, we're not going to get into specifics, but the insulation is of a lower quality, but as you're running, because your voltage is lower, your draw, okay, to do the same amount of work compared to 600 volt, your draw, like, let's just talk, if you would be drawing 15 amps with the 440 volts to do the same amount of work, on 600 volts you'd be drawing 12 amps, let's say. So you increase the voltage, you lower the amperage. So because you increase the voltage, you need better insulation in the motor winding and the wire because of the voltage. But you decrease the size of the wire. Like, you're just to talk there, before you used to need number 10 to suffice for the amperage. Now you just need number 12, and it's big enough, eh? So it's not a free game all the way through. There's equations, and it's part of the systems. Now, okay, to get to what Noel asked about, I'm just gonna it's to do with houses, okay, and it's relating to, I think, relating to here in Canada. We have 115, 120 volt outlets in house. And in Europe, they have 440 volt outlets in houses. So next time, that's what we're going to talk about. But I wanted to start with this to show that there's not one system, and things have evolved through time and have changed. And of the age that I'm at, I've seen I didn't see the first system, the DC. I've seen the leftovers of the DC systems. Like in the latter video, I talked about the buried cables there. Well, that was, we were on an island, and there was a guy, I didn't mention this, but now it comes to mind, There was a guy, his name was Philemon Wright, and he owned the island. He was I think he was a farmer, I think. Had his own powerhouse. That's in the 17-something. Had his own powerhouse, and I guess he was buying his stuff from Thomas Edison, because it was all DC. But the cables, like it was 1,000 MCM, the size of that single conductor that was buried, and there was two. Okay, it wasn't even one cable with a bunch of conductors in it. It was two conductors, so it was positive, negative. Okay, it was going to a certain place, and I know, and this is only what I heard, supposedly there was a set of conductors going out to his house from the generating station, He had his own generating station. He must have, I don't know, Thomas Edison must have installed it for, I don't know where they were getting their, it was in the Thomas Edison days, and he had chosen DC because I think, I don't remember the year, but there was a fair in Chicago, and I think Thomas Edison was given the contract to electrify. That was one of the initial lighting installations, and Thomas Edison got it. And that's how they publicized the electricity. Like most, don't forget, in those days, like like a little bit later there, when the houses started to get power, well, you had 2 fuses in the house, and you didn't have no 220 range. All you were getting, the first initial installation, you were getting 2 fuses. You had single phase, not 2 pole, it was single phase, 2 fuses, and that's it. That's all you had. And I seen breakers, 50 amp breakers. That's how the power came down from hydro into the house panel, which they were puny little things. They had 6 fuses, and 1 block, and the block was for the stove. They started to get the 220, 240 stoves. But that's how it grew to where now we have 60 circuit panels, and probably bigger than that, size like that, and there's no end, But because now, that's another topic, I know some people like Grampy's workshop in there. He's insulating his shop, and he said he's going to do some electrical. Well, I'm going to talk about this one day. It's a big topic. Well, in my mind anyway. Okay, I jabbered enough with this one. Just to show how there was differences, and this still exists, and we still have to expand on it, the differences between America and Europe, and how that came about, and why we have different systems. Okay, stay tuned. Comments are welcome. This is your chance to subscribe to this channel, and we'll see you in the next one.